Okay, so we're going to look at some section 6.5. This is called Applications of Quadratic Equations. And one problem here says one number is 3 more than another number. The difference between their squares is 81. What are the numbers? So there's really kind of a mix of problems in this section. And this particular problem, we have to figure out how to set it up. And we're going to find these two numbers that fit this particular pattern. So in the tutor mode, what they're going to kind of do is walk you through step by step. And with word problems, one of the big challenges is just kind of assigning labels to things. And actually, I'm going to back this up a little bit here. Going to assign labels to things and then find out the appropriate variable combination to put with it as well. So giving things labels and then figuring out how to put the algebra to it is what they're kind of going through right here. One number is 3 more than another. The difference between their squares is 81. What are the numbers? Well, I looked ahead to see kind of how they were going to describe things, and they kind of do the labeling with the smaller number, the larger number. I don't know if you can see that or not, but it says x and then x plus 3. So abstractly, we can just say the bigger number is 3 more than the smaller number is x, and the larger number is x plus 3. So we're just kind of doing some labeling. And then in the next step it says, if the difference of their squares is 81, we're saying x plus 3 squared, take away x squared, should equal 81. So that becomes the problem to solve, and I can't, they just want the answers right here, so I can't really show you step at a time what to do from here to solve that. But what I can describe to you is that you can basically take x plus 3 and multiply it with itself. So I'm doing this on paper right now while I'm talking to you. And you have take away x squared equals 81. And if you have x plus 3 times itself, that's a FOIL problem. Okay, you're going to do that out all the way. You're going to have x squared plus 3x plus 3x plus 9. Take away x squared equals 81. The x squared and minus x squared will cancel, and you're going to be left with 3x plus 3x, which is 6x, plus 9 equals 81. Subtract 9, subtract 9. 6x will equal 72. Divide by 6. X is going to end up being 12. So to fit their pattern, it looks like 12 is the smaller number because that's what we originally labeled as x. The larger number was 3 more than that, so that should be 15. Okay, hopefully that's clear. I'm just kind of talking through it, but the work isn't there right there in front of you, so let's see what else they ask us here. One number is 4 more than another. The difference between their squares is 72. What are the numbers? So again, we're talking about the same type of information. How do we set it up? One number is 4 more than another. Well, if the first number is x, then x plus 4 is the second number. And what is the solution? Well, I'm going to multiply x plus 4 by x plus 4. Take away x squared equals 72. I'm doing it out on paper right now. X squared plus 4x plus 4x plus 16 minus x squared equals 72. X squared and minus x squared cancel. 4x and 4x is 8x plus 16 equals 72. Subtract 16 from both sides. 8x is going to equal 56. Divide both sides by 8. X will end up being 7. So the smaller number is 7. The larger number is 10. Nope, sorry, actually 4 more, right? Thinking of the previous problem. 4 more than the smaller number is 11. Okay, let's see if we get another type of question here. Alright, so this is worded a little differently. One positive integer is 3 less than twice a number. The sum of their squares is 389. Find the integers. Okay, so it's a similar game, but the wording is slightly different over here. One positive integer is 3 less than twice another. So remember that an integer is just a positive or negative counting number, or 0, but I don't think you need to know that. Basically just following the steps, they're telling you what type of solution it's really going to end up being. So one positive integer is 3 less than twice another. So I guess we can expect that if the smaller of the integers is x, then 3 less than twice a number is going to be 2x take away 3. Okay, hopefully that makes sense. 3 less than twice the other number would be represented algebraically as 2x minus 3. Okay, and then they talk about if the sum of the squares is 389, then x squared plus 2x minus 3 squared should equal 389. So what I can basically say about this problem from here is that if you take the 2x minus 3 and you FOIL it out, 2x minus 3 times itself, and then you add it to the x squared, and you do all that, you subtract the 389 from both sides, you're going to end up with 5x squared minus 12x minus 380 equals 0. So they magically just say, give me the answers for the smaller and larger integers. But you got a crazy problem to try to solve right there, because you can't factor anything out as a greatest common factor. So you got to think of, with the outside and inside, two numbers that multiply to give you negative 1900 and add up to minus 12. So if you have some trouble with that problem, and those are astronomical numbers. So what I did is I actually took 1900, and a little trick that I've used in the past on really huge numbers like this is that I took the square root of 1900, and it ended up being like 43 point something. And that gave me an idea that if I choose numbers kind of close to there, I'm probably going to get pretty close to the answer for something that would add up to negative 12 in the middle. And so I ended up with a combination of minus 50 and plus 38. And then when I did the rest of the workout, did the solving, all of that, I ended up with negative 38 over 5 as a solution and 10 as a solution. So I'm going to take back what I said before about the integers and not necessarily needing to know what an integer is, because one of the answers is not an integer. It's a fraction that can't be simplified into an integer, negative 38 over 5. So the only true integer is 10, and then the relationship to that with the other one was that it was double that, take away 3. So if you double 10, you get 20, and you take away 3, you get 17. So those should be your two solutions.